Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 654. Maximum binary tree. You are given an integer array nums with no duplicates. Okay? A maximum binary tree can be built recursively from nums by using some algorithm. Let's see this algorithm. Create a root node whose value is maximum among these nums. All elements in that nums. Okay? Now, what is second thing? Recursively build the left subtree on the separate prefix to the left of the maximum value. And same thing for the right subtree also, but for the separate prefix. Okay. Then return the maximum binary tree built from the nums. Okay. Let us understand what this question states. See this example. Let us say this is the input. Okay. Now, for this input, I want to give an output something like this. But how it is constructed? Okay, fine. What's the first step? We want to take the maximum, right? What is the maximum element? I can say the maximum element is this 6, right? And this maximum element in this whole array is 6. Okay, 6. Now, what they are telling in the second algorithm step, we want to take the prefixes for left subtree, and suffixes what? A right subtree. So take it. So if I take it, this 3 to 1 are belong to what? A left subtree for the 6. And this 0, 5 belongs to what? Right subtree of the 6. Okay, hold on. Now, in the next level, in left side, what is the maximum value? I can say the maximum value is 3, right? So put this 3. Now, what is the suffix of this 3? 2, 1. So this will be what? In right subtree. What's the prefix of this 3? Nothing. So, what is the left subtree? It is null. Can I understand this? Yes? Now, again, hold on. Now, what is the right value of 3? It is 2 on 1, right? 2 on 1. Now, what is the maximum among this 2 on 1? I can say the maximum among this 2 on 1 is 2 only, right? 2 only. So, I can say 2 is the next element. And what is the prefix of this 2? Nothing. So, I put what? A null. What is the suffix of 2? Only 1. So, I put 1 here. Okay. Now, for this 1, what is the maximum value? 1 only, right? 1 only. So, I put just 1. And what is prefix and suffix? Nothing. So, it will be null. Here also null. Same thing we are done. Now, going to what? The right side also. For the 6, what are the right side elements? 0 and pi. Okay. Now, what is the maximum among them? I can say the maximum among them is 5, right? This 5 is the maximum among them. So, just put it. Now, what is the suffix of this pi? Nothing. So, put a null. Now, what is the prefix of this pi? Only 0, right? Only 0. So, let us wait. Now, this should be my array now. Now, what is the maximum element in this array? It's only one element, 0 only, right? So, I put 0. What is the suffix of this 0? Suffix is null. And what is prefix? Prefix also null. Because that is nothing, right? So, this should be my tree. Hope you understand this. Yes? அப்படியே இந்த இடத்துல பாஸ் பண்ணிக்கோ. இப்போ கண்டினியூ பண்ணி. Now, what is the logic behind it? Let us understand first. See here, first of all, what is our array? It is something like 3, 2, 1, 6, 0, 5. Fine. Now, what is my first step? My first step is to find what is the maximum amount of, right? See here, they have given the algorithm. Now we want to write only the code. It is so simple. Okay. So see here, what is the maximum? I can say it is 6. So what is the index? 0, 1, 2, 3, 4, 5. So I can say 3 is my index now. 3 is the index now. Take the 3 in third index and create a node for it. Okay, I create a node for it. Okay, fine. Now recursively go to the next level. So here, what we are going to do? We are going to do a DFS traversal. Why we are going to do a DFS traversal? Because we want to do left, right. So I can say it is what? A DFS traversal. So we are going to do the S. No. I put 6 now. Okay. What is the left subarray and what is the right subarray? So I can say this is our prefix and this is our suffix. Okay, fine. What is my next step? I want to go to the next level, right? So I will send, what are the elements here? 3, 2, 1. Are the elements, right? So instead of sending this whole array, we can send what? 0, 2 is my range now. 0, 2 is my range now. Okay, now, what is the 0, 2? It is 3, 2, 1. Now, I want to find what is the maximum among them. What's the maximum among them? So, I can say the maximum among them is 3, right? So, put 3 here. Put 3 here. Find, put 3 here. Now, again, I want to go to the left side. Okay, 3 in this is what? 0. Now, when you're going to left, what should my in this? It should be like 0, and it is reduced to what? -1. Because 3, I taken 3. So what is my right in this? It reduced to -1. So I can say further there will be no more recursion term, right? So I should take this as null. Take this as null, and I want to return what? A null to it, which means what? There is a root 3, and its left is what? A null. Okay, now I'll go for right. While going for right, what is my in this value? It is from 1, 2. And this is from 1, 2. Okay, among this, what is my maximum element? I can say the first this is the maximum element, right? So I put this here. Now for this first element, again, I want to go to the left side, right? While going to the left side, what should be my array? It's something like 1, 0, right? Because the starting value is 1, and the ending value will be what? This in this -1. So it will be 0, and I have a contradiction. Because starting value is greater than the ending value. So I cannot go further, right? So it also returns null, which means what? There is a node 2, which left is what? A null. Okay, now it's time to go for the right side. While going to the right side, what is my range? Range is something like 2, 2. And 2, 2 is what? First node. First node is the maximum. And while going this side, it will be something like what? 2, 1. While going this side, what is my range? It will be something like 2, 3, 2, right? 3, 2. So both are what? Out of range. So I will return what? A null from both sides. Null from both sides. Now just observe. Now is the most important thing I have to do. Now we'll just returning it. I want to return what? This 1. I want to return this 1 as the right side of this 2. Can you understand this? Now, again, this for this node 2, I believe the left subtree and also right subtree. Now it's time to what? Time to again return what? This 2. So this 2 will be what? Return as the right side of this 3. Okay, again, this 3 is left and right are finished. So this 3 should be returned to what? This 6. So 6 is something like a node. For this left side is what? 3. Can you understand this? Now it's time to what? Time to go to the right recursion call. Okay, going to the right recursion call. What is the range? Range is something like 4, this is what? A 4, and this is what? 5. So 4, 5. Initially my range is what? Initially my range is 0, 5. That's why it is in third range, third in this, right? So that 2, 3 and 4, 5. Can you understand this? Okay, now in this 4, 5, what is the largest value? I can say the 15 this is the largest value, right? So create a node for it. Create a node for it and go further. When I'm going to left, what should be my range? My range should be something like 4, 4, right? 4, 4. And what is the 4, 4 maximum in this? Sorry, maximum value. I can say it is 0. I just placed 0. Wait, again I'm going to left. Again I'm going to left. What should I do? I should reduce this 4, right? And reduce the end to -1. Okay, so it will be 4, 3. So there is a contradiction. So we just written what? A null to it. Just written null to it. Then we go for right. While going right side, it should be like something like 5, 4. Right? So it also does what? A null. Okay, no. Both are finished. So this 0 also written what? 0. I just written what? 0 to it, which means there is a node y for which the left is what? A 0. Again, I go for right side. While going for right side, what is my in this value? It is y. See here, it is like I took the 5. I took the 15 this. So while going here, my index would be what? The starting point will be 6, right? So 6, 5. So that's a contradiction. So we written what? Null. So it indicates what? 5's right side is null. While returning it is what? Null. Okay. Now for this 5, I finish left and right. So it's time to what? Return this 5 here. So by returning this 5, I can say for the 6 node, I can say here it is 5. Right? And then for the 6, again I will return 6 here, right? This 6 node, node 6 will be returned. So I will return the function call. That's it. We got output, right? So it is so simple because they have given the algorithm how to construct. Okay, what is the time and space function? I can say my time and space function will be O of n for time, right? Because I'm just traversing this array only one time. Okay, now what's my space function? I can say my space function will be O of, see here, I go up to what? Up to the depth of this height, right? The recursion stack will be what? Up to the length of the maximum height. So it will be what? O of h. H stands for height. Now, what is this method signifies? This method name is divide and conquer. So this method name is what? Divide and conquer. Just divide and break down the problem, then conquer. Then again divide, conquer. Divide, conquer. It is like what? Breaking a larger problem into sub problem. Okay, like British just divided the India and ruled, right? That's the algorithm here we used, divide and conquer. Now see here, this is the code. Def create of start comma end. Then if start is greater than the end, then what should I do? Just return it. Understand this? We are taking a end is, and if the start end is greater than the end is, then I should return like return none. If you return simply in Python, it is what? Null only. That's what I done here. Now index is equal to start. Now my goal is what? To find the maximum element in my range, right? So for that, I just loop from start plus 1 to end plus 1. And I'm just taking whether that current end is greater than my maximum element in this. If it is so, I just update it. Okay, now I should create a node for the current maximum elements in this, right? So I just created. Now root dot left is equal to, I'm just calling a recursion function. A recursion function for what? Start, comma, index minus 1. Index is what? Index is the maximum element in this. So minus 1 means what? It's parent. So it is what? Prefix array. I sending what? The prefix array again into a recursion. Then again, root dot right is equal to create of index plus 1, comma end. I'm taking the suffix array and those indices and sending to what? Setting the range to the recursion dot again. Now, return root at last. So what it returns? Whatever it returns will be stored in what? In the previous recursion call for this root dot left and this root dot right. That's what this means. Okay, if it doesn't exist, it will return what? A null, which also will be what? This root left and root right value. Can you understand this? Yes. Now, at last, return create of 0, comma, len of nums minus 1. So I'm just calling this function. Let me submit it. Yes, it is submitted successfully. Thank you.
The other after dot nom.
Yes, so very basic.